Python is used for iterating through arrays or lists. Essentially, the loop will go through each element in the array and carry out some set of instructions for each value. If you would like to read all of the elements in an array and compare them to some value or perform some operation on them, a for each loop is extremely useful. So for example, we could have a for each loop which iterated across an array and simply printed out the value of each array location. Next up, we have the while loop. A while loop will continually carry out its instructions while a conditional statement given to it is true. This can be as long as a certain variable is true, as long as a number is less than another number, or while a value is still equal to another value, for example. While loops are different than for loops in that the loop is not contained within one statement, but stretched out and will continue to run as long as this condition is true. Like a for loop, you could make the condition such that it will eventually return false and exit the loop. However, while loops will not crash your computer should you create an infinite loop. In fact, it is very common for while loops to run infinitely, as, for certain programs, you would like the program to continually be iterated through instead of running once, all the way through until you exit out of the program. When programming a game, for instance, a while loop would be used to iterate through your code, continually refreshing the screen as the game runs. From there you could perform operations on the screen to make the game playable. Creating an infinite while loop could be done by simply using the syntax while true, as the condition true will always be evaluated as true. Finally, I'd quickly like to cover the extension of a while loop, the do while loop. Do while loops are very similar to while loops, except they will carry out their instructions at least once, even if the condition is false, and then will carry on like a basic while loop. Essentially, the conditions inside of the loop will run at least once, and then if the condition is still met, they will run again and function as a normal while loop would. As you can see, loops in their many varieties have some extremely useful functions. Using them, you are able to perform an operation many times in a row, you can iterate through arrays and lists, and overall decrease the clutter of your code.
Next up, we're going to be taking a break from learning about common programming statements and dive into what happens when the code we write doesn't work. More specifically, we'll be covering the different types of errors that can occur when you're programming, and what causes them. Now, when you're writing code, you have to understand that things aren't always going to go the way you expected them to, and sometimes the program doesn't always work as you had intended it to. We programmers call these errors, and while annoying, they are always going to come up in computer science, and so it's best to learn what they are and how to deal with them. Often referred to as bugs, errors in scripting languages can be narrowed down to one of three types: syntax errors, runtime errors, and logic errors, all three of which we'll be covering in today's video. To kick things off, let's talk about syntax errors. These are usually the easiest of the three to solve, since they are oftentimes something that can be fixed within seconds. If you remember back to earlier in the video when we talked about syntax and programming rules, we said that if you were to break the programming rules, or syntax, that it would result in an error. Well, that's what syntax errors are. Parts in your program where you fail to meet the programming rules, and so the computer doesn't know how to interpret your code. This can be anything from forgetting a semicolon at the end of a statement in Java, accidentally defining a variable with 2 words instead of 1, or even just misspelling the word string when you're trying to define a string variable. Lucky for you guys, these errors are extremely easy to fix, since you just need to figure out where the error occurred and what the syntax rule you broke was. Now, thinking back to IDEs, we mentioned that IDEs are so useful because they do precisely that. They underline the syntax errors and usually provide helpful hints as to how to fix them. Think of syntax errors as small misspellings or grammatical errors in an essay you're writing. Annoying, yes, but not the most infuriating things. Another useful thing about IDEs when it comes to syntax errors is that the program will actually restrict you from running the code unless all syntax errors are cleared, making them even easier to identify and fix. The second type of error we will be covering is the runtime error. These errors don't show until you actually run the code, hence the name runtime error. Runtime errors are usually caused by a statement in your code that seems logically sound, but the computer physically has no way of computing it in a reasonable amount of time. The most common of these errors is one which we've already talked about, the infinite loop. As a refresher or an example, think of an infinite loop like this. Say you sat your friend down in front of the TV, put it on The Office, and told him he could leave as soon as Michael made a "that's what she said" joke. Seems pretty simple, right? Wrong, because instead of putting in The Office, you put in Friends on Blu-ray. No Michael, no inappropriate joke, meaning your friend would be sitting there for the rest of his life. This is basically what happens with a computer. You give it some condition that it has to complete before the program can terminate. However, you give it no feasible way to finish the task. This puts the computer in error mode, and most likely will crash your program, as the computer desperately tries to complete the condition you gave it. As a computer example, if we try to have a program terminate when integer I is no longer greater than 99, but I is initially 100 and only ever increases, the loop will never terminate, and the program will crash. To avoid these, you generally want to think through the flow of your code before running it, especially with loops, to make sure that all of your statements can be completed by the computer. Carefully planning out your code before you begin writing is an extremely useful practice, and something we'll be covering towards the later part of this video. The final type of error that we will be covering is a logic error. This error is also pretty self-explanatory. A logic error occurs when the code runs smoothly without any runtime or syntax errors, but the result that you get just isn't what you wanted. For example, let's say you had a calculator app, and you wanted to instruct the program to add two numbers, except it multiplied them because you used the multiplication symbol on accident. This leads to the sum being 36 instead of 13. Nothing went wrong with the code syntax or runtime wise. The code runs just fine, it just doesn't work as you had intended it to. These are often the hardest types of errors to debug, since most of the time you'll have no idea why the code isn't working, and certainly not any idea of how to fix it. This is why it's a good idea to test your code incrementally. Don't wait until you've been programming for an hour before testing your application, or else you'll run into a lot of logic errors. Logic errors can be extremely infuriating, and could cost you a lot of time, making them a huge pain. But if you know how to effectively debug your code, you'll be just fine.
Speaking of debugging your code, that brings us straight into our next topic, which is how to debug your program. Now, let's say you've written a program. You think it's ready, and you're ready to test it. You've been working hard on this, and you're excited to see it in action. You run the program, and wait for it to run smoothly and efficiently. Only it doesn't work. You've encountered one of the three errors we just mentioned. You really want this code to work, but how? This is where debugging comes into play. If the code is giving you an error, then the first thing you should do is read the error. Oftentimes, for syntax and runtime errors, the IDE will print an error message out to the console. See what line or lines it points to, since those will be the lines that the error occurred, and see if you can understand and fix what the problem is. If the error isn't clear, or you've never heard of it, then try Googling it, as there are many websites out there such as Stack Overflow, which serve as forums to ask and answer problems with code. Chances are, if you've had a problem, someone else has had the same issue, and there is likely a tested solution. Usually, when the syntax or runtime error pops up, you should be able to find a fix for it fairly easily. However, as I said before, the issue may arise from some loophole or oversight in the code you hadn't planned for beforehand. Maybe you did something as simple as multiply two variables instead of adding them. These are logic errors we talked about previously. These problems usually won't have red text show up to explain what went wrong. You'll have to figure it out yourself. Now, there are a few different strategies that you can use in order to track down and fix a logic error. First, you could use print statements and the console in order to determine where the code is going wrong. Imagine you have a conditional statement that will run one segment of code if an integer x is greater than 5, and will run another segment of code if not. If, in your program, x is supposed to be greater than 5 when the program reaches this conditional, but for some reason the program is still printing out x is small, you could use a print statement to help. For this problem specifically, you could place the print statement before the branch of the conditional that would print the value of x. Now, when you run the program, you know exactly what the computer is thinking. Printing out the value of x just before the if-else statement will let you know if the variable has the value you wanted to have, and if it doesn't, you know that somewhere above that conditional something went wrong and x was set to a value you didn't want it to. In this case, x is equal to 2, which is why x is small is being printed out. Now that we know what the problem is, we can track down where and when in the code we modify x in order to solve it. Use print statements to determine where your program goes wrong, and then try to track down the cause of these issues and solve them. If you use this strategy, make sure you end up deleting the print statements afterwards to avoid clutter in the console. The situation described above could also be solved using a breakpoint. A breakpoint pauses your program when the line you placed the breakpoint at is reached. If, say, you would like the program to run through a certain conditional and set a variable based on that conditional, but you are unsure if this actually happens in your code, you can place a breakpoint inside the conditional path that you expect to run. Upon the breakpoint being reached, the program will pause and wait for you to continue it through a button press. This signals that the spot in the code where the breakpoint was placed, in this case the correct conditional path, has been reached by your program. You can then continue the program knowing that this was or wasn't where the error in your code occurred. Breakpoints can be used in conjunction with print statements in order to both pause the program and perhaps view the values of your variables at the moment in time to give yourself all the information you could want. You can also have multiple breakpoints to help slowly work your way through your program and determine where an error has occurred. A combination of these two strategies will help you easily determine where in your code you have incurred a logic error. Next, let's go over what to do if you think you have tracked down the section of code that causes the problem. You may think you should delete it, but it's likely you put it there for a reason, and you don't want to lose all that work if you don't have to. Firstly, try commenting it out. Comments are used to mark up code and explain their surrounding sections, but they can also be used to debug. Anything that is designated as a comment will not be read by the program as code, and will be skipped over. Essentially, it becomes something that is only there for you, the programmer, to read. The syntax varies from language to language, but it usually involves placing some symbols before or around the code you would like to be commented. Examples of how to comment in different languages can be seen on the screen now. Also, when you comment something, the IDE will grayscale that line of code, making it extremely easy to determine what's commented and what's not. Commenting code deletes it in the computer's eyes without actually deleting it. If a problem is present before you comment a section of code, but it is gone afterwards, then that section of code is the culprit. If you comment part of the code out and there are still issues, then move on to another section until you find the culprit. Once you do, you can tweak it until it works as intended, or delete it entirely, and you'll have a fully functioning program once again. Now that we've talked about what to do if you've encountered an error, and a strategy on how to find and fix it, I'd like to talk about some strategies you can use to avoid errors in the first place. Firstly, back up your code frequently. In the event of the code completely bugging out and you being unable to fix it, you will want the ability to revert to a previous version where the code was still working. If you save frequently enough, then you will probably not lose too much work. Version managers like GitHub or Subversion can help with this, as they back up code to an online cloud service in which you can easily pull previous versions of the program from at any point. Also, on top of saving, run your program frequently to ensure that the current version works as intended. This accomplishes two things. First of all, it prevents you from saving a backup that doesn't work. Secondly, if you encounter a problem, it will be easier to find if you have only made a small number of changes since the last time you ran it and it worked, and thus you will only have to look through the new code for problems. If you've spent 5 hours coding and hadn't run it during that time period, it's going to be likely that at some point during that 5-hour code sesh you messed up, and it's going to be even harder to figure out where you went wrong. Errors, while annoying and extremely frustrating, are a fundamental part of making you a better programmer.
Alright, now that we've covered errors for a bit, let's hop back onto the programming statement train and talk about one of the most important concepts in computer science, the function. Now you may not know it, but we've actually been talking about a few functions this entire series. Print statements, for loops, and even the basic math operations we've talked about are all examples of functions, which of course begs the question of what actually defines a function. Well, a function is a segment of code that can be easily run by calling the function name, and depending on the type of function, will do something in return. Functions can be called numerous times and in numerous places in your code. Essentially, they are like wrapping up a segment of code into a nice present and giving it a name, which, when called, will unwrap the present and go through the code that you had wrapped up. For example, the print statements we have been using this series allow us to print something to the console anytime we want. Those are functions. You see, we just call the print function and enter in what we want to be printed to the console into the parentheses, and the computer does it for us. Behind the scenes, there is actually even more complex code that is in charge of taking your text and translating it to the console to be printed. The developers of almost all programming languages realize that you don't want to program something that manually has to print something to the console through the use of complex programming, and so they implemented the print statement to reduce the stress and complexity of code on the user, abstracting it to the single line of code that is print. All of that code that is used to print something to the console is wrapped up like a present and given to us in the form of one line. This is actually the main theme of all functions and the backbone of any good program. Oftentimes in your program, there are going to be sections of code which are repeated and serve the same purpose, or equations which you want to allow differing inputs of. And so you can use functions in order to condense these down into singular lines of code to save both time and reduce clutter on your code. As you will see soon, functions are extremely powerful, and will definitely be something you utilize all the time in your computer science journey. The print statement is just one example of functions in everyday code. There are thousands of functions that are available to you through the IDEs. However, because we won't always use all the functions that are available to you in a single program, you have to import these functions from packages found in the IDE, which is something that we'll be covering later on. Now, there are four main types of functions in most programming languages, and they are separated by two defining features: whether or not they take in arguments and whether or not they return values. Let's start by separating them by whether or not they take arguments. But first, we have to cover what arguments actually are. Arguments are essentially variables that we pass into the function in order to be manipulated and then either returned back to us, printed to the console, or used in another operation. Think of functions with arguments like this. If you walked up to your local Five Guys and told them that you wanted to get food without supplying a type of food, they would probably look at you confused. In order to get the food that you want, you need to tell them exactly what you want to order so that they can give it to you. In this case, getting food is the function, and what you order in terms of food is being passed in as the argument. Based on what you tell them, or the argument that you pass into the getFood function, they will do something different. You should also note that the argument can be many different things. It could be fries, burgers, sodas, really anything on the menu, and such is the case with arguments in programming. Arguments can be strings, integers, arrays, pretty much anything. As an example of a function that takes in arguments, let's look at the max function, which takes in two integers as arguments and returns the maximum number between the two. Now for this function, if you don't input two numbers or variables for it to compare, it's going to throw you an error, just like the Five Guys employee. He doesn't know what you want to eat since you didn't provide him with any arguments, and the computer doesn't know which two numbers you wanted to compare and return since you didn't provide it with two integers. Arguments are a way for programmers to have one function that can do many different things depending on whichever variables can be passed through. Arguments add variability to programming and can help diversify your code. Think of it like this. A restaurant that only allows one type of food to be made, regardless of what you order, isn't going to be very useful or diversified. But if we're able to pass in arguments and tell them which food we want, our experience can be heightened and more options can become available to us, which is exactly what happens when you start using arguments in your function. Now that we've talked about functions that take in arguments, let's move on to functions which do not, because functions can also be created and used without taking arguments in, and still be incredibly useful to the programmer. For example, let's say you are making a text-based RPG game, and one of the options you give your player is the ability to view their stats at various points throughout the game. Now every time you come upon this option, and they choose the View Stats button, you don't have to type out 6 different print statements for every statistic they may have. Your code would get cluttered and messy very quickly. Instead, what you could do is you could package the 6 different print statements in a simple function called print_stats. You don't need to pass in any arguments into the function, since the function will do the same thing no matter what the statistics on the player are. Now, every time the user wants to view their stats, you could simply call the print_stats function, and voila, the user's stats are printed for them to view. This allows you to save a lot of time writing code, but also a lot of space, which is extremely important when your programs begin getting into hundreds and thousands of lines of code and you want to easily search through it to maybe debug. Okay, now that we've separated functions into those that take arguments and those that do not, let's again split these up into those that return values and those that do not. Now the thing you have to understand is that when you're making your own functions, which is something that we'll be covering very soon, you have to choose what your function will return, if anything at all. Functions are able to return values back to the user, whether they be in the form of string variables, integer variables, or even arrays. Now the thing to note about returning variables is that calling the function alone won't do anything. You have to return the value into something, or print it out. As an example, the max function we talked about previously would return an integer back to the user. But in order to do something with it, we would have to either set a new integer variable equal to the result of that max function, or we can print out the result of the function, which in this case would just print out the maximum value between the two integers. Using functions which return values don't do much on their own. You have to pair it with something in order to gain the use from it. Let's do another example. Let's say you had created a function which took in two string variables as arguments and combined that using that fancy string math we talked about earlier, and then returned them as a singular string. This combined string function could then be used to create new string variables, since what it returns is basically a string. The variable would simply be set to whatever is returned from this combined string function. The last type of function is one that does not return anything, and these are known as void functions. Oftentimes, these are like the print stat functions that we created earlier, simply used to condense large amounts of print statements that appear often in your code. These cannot be set to variables, since they don't return anything and just get the code that's within them run through. So there you have it, the four types of functions: ones that take in arguments and return something, ones that take in arguments and don't return something, ones that don't take in arguments but still return values, and ones that take in arguments and don't return anything. Each of these four types of functions are useful and unique in their own way, and you will probably find yourself using each of them through your programming journey. So get used to the different types of functions, and know how to make the most of them, as they are all extremely powerful. Finally, I'd like to talk about one of the major benefits of functions, which is that it makes it super useful to make large changes to your code without having to go through the entire program. Each function call is essentially just a copy of that function's original code, and so it's very easy to make changes to that initial function and have it translate across your entire code. Let's go back to our print stats function and say that you wanted to go back and add in a new statistic that the player could level up and through experience in the game. Without functions, you would have to go back into your code and find every instance that you had printed out the user's stats and create another print statement to display the new statistic. However, if you had created a print stats function like we did just a while ago, all you would need to do is find out where you define that function and add in a print statement which displays the new statistic, and you're done. Now, every place which you had previously called the print stats function will now also print the new statistic as well. You can see just how powerful functions can be if used properly, and we haven't even scratched the surface yet.
Now, up next we're going to cover how we can import other people's functions that they've written and use them in our code. Now before we get technical, close your eyes and imagine you are trying to build a house. Sure, you could grow your own trees, chop down your own wood, make your own tools and nails, and build it from scratch. But why do that, when you can simply go to your local Home Depot and buy these materials that others have already made ready for you? That's the main idea behind importing functions into your code. Importing functions allows you to gain access to libraries of functions that other people have already made for you. This is just as useful as it sounds. There are so many functions that are super useful for any given program that it would take you forever to write them all yourself. Luckily, other people have already done most of this for you. In each programming language, you are able to use an import statement to import libraries of functions into your program that you can use as you write it. A library is simply a collection of functions that all have the same theme. It may be a math library, a data analysis library, a library which translates text, or anything you can think of, really. There's such a variety of libraries for any given language that most functions you require that are not hyper-specific to your program can likely be found in some library. In fact, a good portion of any programmer's job is looking online for packages which can make his or her job easier, instead of handwriting functions. Now I can hear you saying, "Wow, that's sick! How do I do it?" Well, it's quite simple. An import statement. In most languages, an import statement consists of three parts: the library you would like to import from,